Welcome to Indefinite Integrals Lesson 3, Integration by Parts. Integration by parts is the second technique that we'll study to try to find an integral. It does not guarantee an antiderivative. It just switches one integral for another, and it's based on the product rule, but it itself is not the product rule. It just kind of switches out some things. So right now we're going to use the product rule to show you how integration by parts works. Yeah, it's a little crazy. So here we go. I'm going to start out with a marker, hopefully. Alright, f times g, and if I take the derivative of that, what is that going to be? Derivative of the first one times the second one plus the first one times the derivative of the second one. Alright, are you ready? Okay, there is the product rule shown for you one more time. Now what we're going to do is we are going to integrate both sides. Okay, this with respect to x, and then take the antiderivative, the integral of that. Okay, since integration and differentiation are inverse functions, the left side will just be f times g, and that's going to equal, we're going to separate these up, the integral of f prime g dx plus the integral f g prime dx. So f times g minus the integral of f prime g d of x equals, I'm just subtracting this from both sides, the integral of f g prime dx. So when we look at an integral, when we use by parts, we're going to look at that right there, and that's what we're going to see in our mind, and we are going to evaluate it using this. And hopefully when we do that, we are going to make a simpler integral here that we can actually solve. Alright, so why don't we use the symmetric property that you learned in geometry, the integral of f g prime dx equals f times g plus the integral of f prime g dx. That is how you're going to use integration by parts. So let's see here. Here's a perfect example. The integral of x sine x dx. Okay, what we're going to do is we're going to say, hey, here's our f, this is f, this is our g prime. Okay, so we're going to rewrite that as, okay, f equals x, g prime equals sine x. So what's f prime? 1. What's g? The antiderivative of sine x would be negative cosine x. So f times g, that would be negative x cosine x. That's f times g. minus the integral of f prime g dx. Alright, so f times g, negative x cosine x, minus the integral. F prime is 1, and this is negative cosine x dx. Alright, negative x cosine x. Let's move this negative 1 out front, so that becomes plus the integral of cosine x dx. So the answer is negative x cosine x. What is the antiderivative of cosine x? Of course, sine x. Sine x. And then some arbitrary constant c. And how do you know you got the right answer? By taking the derivative of this and seeing that your result is x sine x. Alright, let's go ahead and move on to the next example. Alright, with these, okay, anytime you have a polynomial function and a trig function, the polynomial function will be f, and the g prime will always be the trig function. Anytime you have a polynomial and a natural log, this will be your f, and this will be your g prime. Always, anytime you have a polynomial and a natural log. So go ahead and set up your f and your g prime. X cubed minus 6x squared plus 2. Go ahead and find f prime and go ahead and find g. And then pause and then look at my answer. Alright, my f prime is 1 over x and my g is x to the 4th over 4 minus 2x cubed plus 2x. So again, the resubstituted would be f times g minus the integral of f prime times g dx. So ln of x times x to the 4th over 4 minus 2x cubed plus 2x minus the integral 1 over x, and this is why we made ln of x the f prime, because this will make a simpler integral to solve than this one up here. So that's why we did what we did. Okay, moving right along, this would be minus the integral of x cubed over 4 minus 2x squared plus 2. When you distribute that 1 over x to each term dx. So minus, hey, put this in this antiderivative in parentheses, otherwise you're going to mess up with these signs here. You know how you guys always do that. So add 1 to the exponent. 4, multiply by the reciprocal 1/4, so x to the 4th over 16, minus, add 1 to the exponent, 3, multiply by the reciprocal, 2/3 x cubed, plus 2x. And this is just all that stuff right there. So my final answer is ln of x times x to the 4th over 4 minus 2x cubed plus 2x minus x to the 4th over 16 plus 2/3 x cubed minus 2x. Yes, this is a 3 right here, yes. And that would be the antiderivative. I think I got time for at least one more. Oh no, okay. Polynomial and a trig. This f will be x squared, and g prime will be sine x. Sorry, I was already moving ahead. So f prime equals 2x, and g equals negative cosine x. So f times g, negative x squared cosine x, minus the integral of 2x times negative cosine x dx. So this would be negative x squared cosine of x. Let's go ahead and move that out front, plus 2 times the integral of x cosine x dx. I move the negative out front of the integral, and I move the 2 out in front of the integral. Guess what? We have to do integration by parts again. Arg! So let's see here. We're going to do another f and g. F equals x. G equals cosine of x. So f prime equals 1. And, sorry, this is supposed to be g prime. And g equals sine x. So we have negative x squared cosine of x plus 2 times, alright, f times g, x sine x, minus the integral of 1 times sine x dx. So let's extend one more time. Negative x squared cosine of x plus 2x sine x minus 2. Okay, the antiderivative is negative cosine, so we'll say plus cosine of x plus an arbitrary constant. Oh my soul, did I forget that on the last one? I did. So sorry about that. Yes, don't forget to go back on that other one and say plus c, an arbitrary constant. My bad. So sorry. So on this one, we had to do integration by parts twice to get the answer. Do we have time for one more? Can I sneak it in? Yes, I think I can. Alright, whoa. ln of x. This time we're going to try something really, really funny. We're going to say f equals ln of x. So that makes g prime have to equal 1. So f prime equals 1 over x, and g equals x. So f times g, x, ln of x, minus the integral f prime times g, 1 over x, times x, dx. Really, I can hear that Candy Crush from here. Minus the integral of 1 dx. Can't believe my wife doing that. X, ln of x, minus x, plus some arbitrary constant. And that's all I can fit today. This does conclude indefinite integrals lesson 3, integration by parts.